Yeah, so we start with chapter 3, which is numerical descriptive measures from your Maths 215 course at Athabasca University. So
Mm-hmm.
we'll be talking about a few measures of central tendency, which are basically referred to as the mean, median, and the mode, the holy trinity as we call them. And they are extremely, extremely important to all of mathematics and statistics worldwide.
Mm-hmm.
So mean is the simplest concept, and you might be very much aware of it already. It is nothing but the simple average of numbers, right?
Mm-hmm. Mm-hmm.
So mean for ungrouped data is basically obtained by dividing the sum of all the values by the number of values in the data set. Simple, right? So
Yeah.
if you go grocery shopping, you like have five items. One is worth $2, the other is worth $10, and so on. You just add them up and divide by five. That's the average price. Simple,
Mm-hmm.
right?
Yes.
So you see two different symbols on my slide. One is referred to as mu, right?
Mm-hmm.
So it's a
Yes.
little U with a tail on the left.
Mm-hmm.
So we write it like this. It's just mu, like this, right? So
Mm-hmm.
all you do is you write a small u and then you have a little tail on the left. And this refers to population mean, right?
Yes.
Population mean or population
Yes.
average.
Mm-hmm.
So if you see on the slide, mu is calculated as summation of x divided by capital N. Since you've done chapter 1, I would assume that you are comfortable with the summation notation now,
Yes.
right?
Mm-hmm.
So summation of x would basically mean all the population parameters just added together and you
Mm-hmm.
divide by the total population size. Simple, right?
Yeah.
Now, mean for sample data essentially is represented by another variable which is called x bar. So it is a little x, lowercase x with a little bar on top, x
Mm-hmm.
bar. This is how you read it and basically refers to sample mean, if that makes sense,
Yeah.
right?
Yes.
So it is the same formula essentially summation of x divided by small n. So capital N for population because population is generally bigger. Small
Mm-hmm.
n for the sample. Sample is normally smaller. Sample size, right? So it's very intuitive if you think about it,
Mm-hmm.
right? So let's do a quick maths problem, a very simple one for you. We have
Okay.
the 2008 sales of six American companies, General Motors, Walmart, and so on. You
Mm-hmm.
have to simply find 2008 mean sales for these six companies. Can you do that?
Yeah. Just add them all up and divide it by 6.
Yeah, absolutely. So I trust that you will get the calculation right. It's fairly straightforward,
Yeah.
right? So you write it as summation of x and you add all of these up, and then
Mm-hmm.
x bar is summation of x over n. Now, question for you here is why
Mm-hmm.
am I saying this is x bar and not mu?
Because it's sample.
And how do you know this is a sample?
Because it says 6, not all companies.
Yeah, six American companies, and then of course there
Mm-hmm.
can be like hundreds of American companies, right? So
Mm-hmm.
we can't really say it's a population.
So
Similarly,
how would you know if it's a population? What would it say? What would the question
yeah,
be?
it would say something like this. So that is the next
Oh.
example for you. So if it
Mm-hmm.
says following are the ages of all eight employees of a small company, this is the population of all employees. So you
Okay.
have to really, impute it from the language of the question, from the wordings of the question, right? So
Mm-hmm.
if it uses words like all, it's typically the population. And if it
Mm-hmm.
doesn't, and looking at the numbers, also you feel that there can be many others in this population. This is just a small subset of what this can be, then
Mm-hmm.
you typically refer to it as sample.
Okay.
Make sense?
Yeah.
So mean age of all employees, so mu, and of course the formula is same, so you don't need to really bother about that.
Mm-hmm.
362 divided by 8, which is 45.25.
Mm-hmm.
Okay, now we come to the second kind of metric, which is referred to as median. Now this might be new to you if you don't have a background in mathematics, but it's fairly straightforward, I assure you.
Mm-hmm.
It is basically the value of the middle term in a data set, which is ranked in increasing order, right?
Mm-hmm.
So
Yes.
how do we find the median? Two
Mm-hmm.
simple steps we have highlighted on the slide.
Mm-hmm.
Rank the data set in increasing order, and
Mm-hmm.
then you find the middle term. The value of this term is the median. It is as simple as that,
Yeah. Okay.
right?
Yeah.
So let's say I have seven houses, right? And I have the prices of seven houses in thousands of dollars. So for example, this is the price of the first house, $312,000.
Mm-hmm.
Price of the second house $257,000, and so on. Question is find the median.
Mm-hmm.
How will we do it? We will
Put them in
arrange it
order.
in descending order. Yeah. So if
Mm-hmm.
you see, this is in random order, right? I have a bigger
Yeah.
number and then a smaller number and then a even bigger number and so on. So
Yes.
I arrange it like this in
Mm-hmm.
increasing order. This is an increasing order if you see.
Yes.
And then what's the second step? Simply find the middle term. Now, if I have seven terms,
Mm-hmm.
which one will be the middle term? Think and answer.
Just 1, 2, 3. The fourth one.
Fourth term, absolutely
Mm-hmm.
correct.
Mm-hmm.
So all I would do is I would arrange it first and then
Mm-hmm.
grab the fourth term, which becomes
Mm-hmm.
my median.
Yeah. Okay.
Is it straightforward?
Mm-hmm.
Yeah.
Mm-hmm.
Now the problem arises when I have an even number of numbers. Because if you look at any sort of a combination of even numbers, let's say if I have 7, 9, 2, 5, 11, and let's say 10. So how many numbers do you see on my screen? Six numbers.
Yeah. 6.
Now, when there is an even number of numbers, which is six in this case,
Mm-hmm.
there is no single middle term, but there are two middle terms, if you see,
Mm-hmm.
right? Because I
Yes.
have two numbers here, I have two numbers here, and two in the middle. If you have an
Mm-hmm.
odd number, like in our example,
Mm-hmm.
then of course the seventh for seven terms, for example, you
Mm-hmm.
have one middle term. So you just grab
Yeah.
that. But
Yeah.
the question is, what do you do when there's an even number of numbers? So I have 12 companies here. 12 is an even number,
Yes.
right? So again, I will have two middle terms. So what do you do
Mm-hmm.
in such cases is fairly straightforward. You first step is the same. You first rank them in increasing order like this,
Mm-hmm.
and then you grab the middle two terms and take the average,
Mm-hmm.
right? So for 12 values, if you think about it, the sixth
Mm-hmm.
and the seventh value will be the middle two terms,
Yes.
because the sixth will be after five terms, and
Mm-hmm.
after seventh term there will be another five terms.
Mm-hmm.
So you grab the middle two, 12 and 13, take the average, and that's your median. Voila.
Okay.
Right?
Yes.
Now,
That's pretty.
yeah. But how do
Mm-hmm.
we quickly determine which are the two middle terms? So for that, you can use
Mm-hmm.
a simple way to remember it. It is the n by 2th term plus n by 2 plus 1th term, and this whole thing divided by 2, the average of these two. So this is your median, where n is nothing but total number of terms. So if n is 6, like terms on this example, the
Mm-hmm.
n by 2th term would mean 6 divided by 2th term, which is third term, if that makes sense. 6 by 2 is 6, 6 by 2 is 3.
Mm-hmm.
Yeah.
Yeah.
And what did I say is the other term? N by 2 plus 1th term. So if n by 2 is 3, and 3 plus 1 is how much?
4.
4. So third term plus fourth term divided by 2. So you take the average of these two.
Okay.
Just for you to quickly find out which are the middle two terms. Because if there
But I
are
can
two,
use the other method as well, right?
the other method is the same thing. Is the
Oh,
same
okay.
thing.
Yeah. Mm-hmm.
I'm just like giving you a more concrete formula here just to quickly identify the middle two terms.
Okay. So it's
Because
n over 2.
if you have like 12 terms here,
Mm-hmm.
you will take a minute to figure out that these are the two middle terms.
Mm-hmm.
But if you have the formula
Mm-hmm.
n by 2 plus n by up and the average of the n by 2 plus 1th term. So for 12, how much is 12 divided by 2?
6.
6. So 6 term and n by 2 plus 1th term. So how much is 6 plus 1?
7.
So you see how it becomes easy to find that which terms am I looking for?
Mm-hmm.
Because when you have like 100 terms or let's say 104 terms, right?
Mm-hmm.
Then
Mm-hmm.
sit in your exam and count as to which are the middle two terms, or will you be smart and use this formula?
Yeah, formula.
Make sense?
Yes. So it's
Yeah.
n over 2?
Yeah. N over 2th term. If you look at the formula here, if you want, I can zoom in. So you have to basically take the average of the n by 2th term and the next term basically. So n by 2 plus 1th term. That's your median when n is even, if that makes sense.
Even.
Don't need to jot down anything. You will have the recording, so you can look at the discussion again. Is
Okay.
it clear? Is it fairly straightforward?
Yes.
Yeah. Now, the third measure of central tendency is called mode. So mode is basically a value that occurs with the highest frequency in a data set, the most frequently occurring value.
Mm-hmm.
So that is what we refer to as the mode. So here, which value do you find is recurring the most?
74.
Absolutely, because everything else is very, very unique. You
Mm-hmm.
have 178, 184, 181, 179, and so on. But you have 74 repeating twice. So the mode is 74, if that
Mm-hmm.
makes sense. Now, you can say that a data set is having only one mode and it's called a unimodal data set. A data set with two modes is called bimodal, and a data set with more than two modes is called multimodal,
Mm-hmm.
right?
Yes.
So, can you find the mode here?
I don't see one.
Yeah, absolutely perfect. There is no mode, as you rightly
Mm-hmm.
mentioned, because all the values are unique.
Mm-hmm.
How about the previous example about the mean? Can you find the mode here? Which are the most frequently occurring values or value?
None.
So, if you look at it, there are two 13s,
Oh, yeah, here, yeah, 2.
right? And
Mm-hmm.
there are two 17s as well.
Oh, okay, yeah.
So, basically, there are two modes here,
Mm-hmm.
13 and 17. And since there are two modes, there are two numbers which are both mode. This is a
Okay.
bimodal data set, right?
Mm-hmm.
So mode is clear. Is it fairly straightforward
Yes,
as well?
yeah, very clear that one, yeah.
Now, one beautiful advantage of mode is that it can be calculated for both kinds of data, quantitative as well as qualitative. So when you
Mm-hmm.
talk about qualitative data, this is how the data will look like. There are no numbers involved. It's just a qualitative, understanding of data.
Mm-hmm.
Now, what's the mode here? Any ideas?
Senior.
Absolutely. Because senior is repeated
Mm-hmm.
multiple times, whereas the others are not.
Mm-hmm.
So this is one big advantage of using mode, that it
Mm-hmm.
can be calculated for this kind of data also.
Oh, yeah, okay.
Right. Now, relationship between mean, median, and mode. So for a symmetric histogram, which looks like this, the three are equal to each other,
Mm-hmm.
and the three are equal to this value of the variable, the central value,
Oh, okay. I read
right?
the book and I was a little bit confused about how they're all equal.
Yeah, because it's symmetric. That's the reason that they are equal.
Okay.
Simple. Now, when you have something which is skewed, can you tell me whether this is skewed to the right or the left?
The right.
Absolutely, because you have smaller bars on this side, as we learned
Yeah.
earlier,
Mm-hmm.
right? So in this case, the mean is actually greater than the median, which in turn is greater than the mode. If you see, the mode is the leftmost, then
Mm-hmm.
comes the median, then comes the mean. If it's the other way around, if it's a left skewed, then the relationship is also reverse. Now the mean is the smallest, the median is in the center, and the mode is the largest.
That's
Make
always
sense?
the case?
That's always the case for something which is skewed to the left.
Okay.
Right. Measures of dispersion. Now we have three different metrics: range, variance, and standard deviation for measuring dispersion. Till now, we were focusing on measures of central tendency. Centrally, how does the data look? So,
Mm-hmm.
mean is like a central measure, the average of all numbers. And then the standard deviation tells you how far are the values spread around the mean, the other values,
Mm-hmm.
right? So the first one is the simplest and is the least used these days. It's not very important these days in our normal industrial standards. It's called the range.
Mm-hmm.
And the range is very simple. It is the largest value in the data set minus the smallest value. That's it.
Okay.
But the problem with range is it has the disadvantage of being influenced by outliers. So if there are too big or too small values, then the range will be influenced by that, but does not give you a good picture of what the rest of the data looks like. So what we look at is essentially called a standard deviation. As you see on the slide, standard
Yeah.
deviation is the most used measure of dispersion. So of course, lower value of the standard deviation. Yeah. So value of the standard deviation, as I was just saying, tells how closely the values of data are clustered around the mean. If the standard deviation is low, then the distribution is tighter around the mean. The values are very
Mm-hmm.
close to the mean, the other
Mm-hmm.
values. If the standard deviation is too high, then the values are farther apart from the mean. As simple as that.
Okay.
Lower value of standard deviation indicates that the values of the dataset are spread over a relatively small range, and a large value of standard deviation indicates that the values are spread out over a large range, as we just noted. Now, there is something called variance. Variance is nothing but the square of the standard deviation. So if the standard deviation is 2 units, the
Mm-hmm.
variance is 4. If the
Okay.
standard deviation is 5, the variance is 25, the square of that,
Mm-hmm.
right? So standard deviation is normally represented by this symbol, which is called sigma,
Mm-hmm.
right?
Yes.
So again, since we always differentiate between the population and the sample, for the population, the standard deviation is referred to as this symbol. It's a little circle with the extended tail on the top, and
Mm-hmm.
this symbol is read as sigma. For the sample, this is given as S, just S, the small s,
Mm-hmm.
right?
Yes.
That's just S. Similarly, for the mean, just for you to draw a parallel in your head, this is
Mm-hmm.
mu for the population. For the sample, it is X bar, if that makes sense.
Yes.
So of course, as I said, if I square up sigma, I will get the variance. So the symbol is sigma squared, just sigma with a square symbol on top. And
Mm-hmm.
similarly for the sample variance, I will just have S square. Does that make
Okay.
sense?
Yes.
Yeah. Now, how do I calculate the variance and standard deviation for ungrouped data? So we have certain horrible looking formula that you see on my slide,
Mm-hmm.
which unfortunately we'll have to use in our exam if you have ungrouped data. But the good news is that these formula will be a part of your cheat sheet. So you need
Okay.
not worry about anything.
Mm-hmm.
So sigma square is the population variance and S square is the sample variance. So sigma square is given by summation of x square minus summation of x whole square divided by capital N, the whole thing divided by capital N. And S square is summation of x square minus summation of x whole square divided by N, the whole thing divided by N minus 1. Now this is where we use different formula for the sample and the population variance. And you have to be extremely, extremely careful,
Okay.
right? So for the sample variance, when you're calculating it, the ultimate denominator here is n minus 1.
Mm-hmm.
For the population, it's capital N.
Okay.
But on the top, it's fairly similar. If you see
Okay.
this whole thing and this whole thing, it's fairly similar, right?
Mm-hmm. Yes.
Is it all sinking
Yeah.
in?
Yeah. This is good so far.
Any questions anywhere till now?
Uh, no.
Perfect, perfect. And of course, if you have to impute or calculate the standard deviation from the variance, you simply take a square root of that. So population standard deviation is nothing but square root of sigma square, and sample
Hmm.
standard deviation is square root of s square. That's it.
Okay.
So the following table gives the 2008 market values of 5 international companies. Find the variance and standard deviation for this data. So how will we approach this? The same kind of approach. We will have our x's as these market values. This is my variable. And since I need x square and the summation of x square for the formula, I will add a separate column for x square and calculate all the squares of these numbers. Fairly straightforward.
Yeah. Is this group data or ungrouped data?
You tell me.
Group data, right?
It's ungrouped data. If you've brushed up your chapter 2, you would know that group data basically means where you have ranges for the class. So upper limit, lower limit, upper boundary, lower boundary. Groupings. This is ungrouped data.
Mm-hmm.
Yeah. So how do we calculate it? The final answer very simple. Now this says 2008 market values of 5 international companies. Is it a sample or is it a population?
That's a sample
And how do you know that?
because it says 5
So
international companies.
yeah, so there can be like 5 million international companies. We don't care.
Mm-hmm. Mm-hmm.
But definitely more than 5, right? Common
Yeah.
sense.
Mm-hmm.
So it's a sample. For a sample, you have n minus 1 as the final denominator. So summation of x square minus summation of x whole square divided by small n. And then you go on doing some calculations and you get this number as your variance, s square. Then
Mm-hmm.
simply take the square root of that, you find your standard deviation. Simple.
Yeah.
Now, one thing to note here is these both of these, like variance and standard deviation, can never be negative. And why is that? Because you are squaring up something. When you square up
Mm.
something, it will always be positive.
Okay.
And when you take the positive square root of that, that number will obviously be positive.
Mm-hmm.
Second thing is measurement units of variance are always the square of the measurement units of the original data. So like when we calculate area, it's centimeter square, not
Mm-hmm.
centimeter, right? The
Mm-hmm.
similar concept. Okay. Can you try this one end to end? Give me the final answer.
Okay.
Mhm. So jot down the data and then I'll bring up both the formula for you and you will tell me which one to use. Once we agree on that, then you can just go ahead and do your calculations. Yeah.
Okay.
Mhm.
Mm. So this one is sample.
It's a sample.
Yeah.
What does it say?
Oh, oh, six. Oh, okay. Oh, I missed the all. I just read the six. Yeah.
Yeah.
You're
So
right.
all six means population,
Population. Yeah.
right? So you've jotted down these numbers?
Yeah.
Perfect. So which formula are we going to use from here?
The little thing with the square.
No. The first
First
formula
one.
or the second formula?
First one.
First one. So let's try to use this and find the variance, and then we'll calculate the square root. So add one column for your x squares. Be very, very careful with your calculations. Do not commit silly mistakes, right? And then let's find the standard deviation.
So I have to find all the x squares for this.
Yeah, absolutely.
No, it's gonna be long list.
Yeah. So I just want you to do this problem end to end so that you are comfortable with the calculations and you don't commit silly mistakes, right?
Yeah.
Hmm. Yeah. So where are we at?
I just did the square. Now I have to add them all up.
Okay, go on. When you have the sum, just give me the sum before applying the full formula so that I can just compare it to what I have on the slide.
Before squaring it or after squaring it?
After adding the squares.
Oh, okay.
Yeah.
Oh, I have 35, 978.46.
Yeah, that's fine. It's 0.51, but does not make a difference. And similarly, summation of x will come to 449.3. Just jot down this value. You don't need to add up x. 449.3. You have the two numbers jotted down?
Yes.
Now just try to apply this formula, please. The first one.
Okay. Can I see the formula again?
Yeah, I'll just go back to it. Give me one sec.
Okay.
Yeah.
Okay. Got it.
Okay. What's the final answer? You have it?
No, I didn't do it yet.
Yeah, yeah. Go on. Take your time. So any luck with the final answer yet?
Just subtracting and I'm gonna divide.
Okay, okay.
I got 388.89.
Mm-hmm. Okay, let's take a look. Yeah, 388.90. So that's the same thing for the
Mm-hmm.
variance, sigma square, right? I'm
Yeah,
glad that you did not commit any silly mistakes here, which
yeah.
many students do. So definitely you are among the better lot. That's a good thing.
Oh, yeah.
And sigma is square root of that number, of course. So it would
Mm-hmm.
come to 19.721.
Yeah, I got it.
Perfect, perfect. Yeah. So that's the standard deviation. And the
Mm-hmm.
data was in thousands. If you recall, we started and said that these are the 2019 earnings in thousands of dollars.
Yes. Okay.
So 19.721 basically means 19.721 thousand. So
Thousand.
basically
Okay.
19721, right?
Mm-hmm. Yeah.
Perfect. So we come to something called mean for group data now and the variance and standard deviation for that. Mean for population data is given by summation of MF over capital N. And of course, mean is a very simple guy. Mean is a very simple formula. So for the
Mm-hmm.
sample also the formula is the same. X bar is summation of MF over small n.
Mm-hmm.
So M is the new thing that we are introducing here. That's the midpoint of every class, and F is the frequency. Right? So I have some data about the daily commute times for 25 employees. This is group data. Now you recall from chapter 2,
Oh,
right?
yes, yes, yes.
When you have classes in terms of ranges like this,
Okay.
right?
Mm-hmm.
So we have daily commute times of 25 employees. The first set of employees commute between 0 to 10 minutes every day.
Mm-hmm.
And how many employees do we have in that class?
4,
Then 9 employees commute between 10 to 20 and so on.
9. Okay.
So if I have to find the mean of this data, I need the midpoint of every class. Midpoint is simply upper boundary plus lower boundary divided by 2.
Mm-hmm.
So 0 to 10 comes to 5. And then 10 plus 20 is how much?
15.
10 plus 20 is 30. Divided by 2 is 15.
Mm-hmm.
So you get these midpoints. You already have the frequencies. So you have to find the summation of MF. And we said in chapter 1 that whatever has a summation symbol next to it, you find that as a different column. So you
Mm-hmm.
find all the values of MF. You multiply
Okay.
each M with the F, go on finding the
Mm-hmm.
products, if that makes sense.
Yes.
Yeah.
Mm-hmm.
And then add these up, it gives you how much? 535.
Mm-hmm.
Makes sense?
Yes.
So summation of MF over capital N is 535 divided by 25, which is 21.4 minutes.
Mm-hmm.
Yeah.
Yeah.
Table 3.1 gives the frequency distribution of the number of orders received each day during the past 50 days at the office of a mail order company. Calculate the mean. So similar process. We add an M, 10 plus 12, 22 divided by 2 is 11. So on. Find the midpoints, find the products, sum them up, and divide by 50.
Mm-hmm.
Sounds good? Fairly
Yes.
straightforward.
Yeah, this is straightforward. Yeah.
And if you have to find the variance and standard deviation for group data, the
Mm-hmm.
formula is again slightly complicated. So for population variance, sigma square, you have
Mm-hmm.
summation of m square f minus summation of mf whole square divided by n divided by n. For
Mm-hmm.
sample variance, numerator remains same and denominator changes to n minus 1.
Mm-hmm. So this is for
Same
the
as
group
the
data.
previous. Sorry?
This is for the group data.
Yeah, absolutely.
Okay. Yeah.
Group data. Similar to the previous set of data that we went over.
Mm-hmm. Mm-hmm.
Previous set of formula is very similar. And of course, the standard deviation is again, of course, it's just the plain square root of whatever you find as the variance.
Mm-hmm.
So same data. Let's try to find the standard deviation now.
Okay.
So for the variance, I need summation of mf and summation of m square f. I will add two new columns apart from the midpoint, which is another new column.
Mm-hmm.
So midpoint, just the midpoints of all of these. mf, which is product of each m and f.
Mm-hmm.
M square f, which is the product of m square times f. Summation of m square f is this number.
Mm-hmm.
So sigma square is nothing but the summation of m square f minus summation of mf whole squared divided by n, and the whole thing divided by capital N. Right?
Yeah. Mm-hmm.
Summation of m square f is this number
Mm-hmm.
14825 minus summation of mf 535 whole square divided by 25, and the whole thing again divided by 25. If that makes sense.
Mm-hmm.
Yeah.
Yes.
So you will get how much? 135.04. If that makes sense.
Mm-hmm.
Similarly, sigma is nothing but the square root of sigma square, and that comes to 11.62. Just be very careful with the m square f because that's where students make the most mistakes. You have to multiply the square of m with f.
Yes.
So
Yeah. Because it says
5
here.
squared, yeah, so 5 squared
Mm-hmm.
is 25,
Mm-hmm.
and that gets multiplied to 4, giving us 100,
Okay. Yeah. Mm-hmm.
and so on,
Mm-hmm.
right? So this example is again the same example for the standard deviation that we did for the mean. Just skipping this in the interest of time, not like very different, it's the same thing.
Mm-hmm.
We come to a very important concept of Chebyshev's theorem.
Chebyshev is the one I had issue with.
Yeah. So Chebyshev's theorem, if you read the definition, it will never make sense,
Mm-hmm.
right? For any number great k greater than 1, at least 1 minus 1 by k square of the data values lie within k standard deviation of the mean, blah, 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 doesn't make any sense.
Mm-hmm.
The best way to do maths is always just to look at an example and understand.
Mm-hmm.
So Chebyshev's is a simple formula to say that what percentage of my curve's area, the
Mm-hmm.
area under this curve, what percentage of this area lies within these bounds. Now,
The
how do I
shaded ones,
define
right?
these bounds? Yeah, allow me to explain. Just allow me to
Okay.
explain for 2 minutes, and then I'll take questions.
Mm-hmm.
So this is my frequency distribution curve or frequency polygon, right? The mean is always in the center for symmetric distribution. This is my mean. We just studied that today, right?
Yes. Yes.
So I have something called standard deviation, which we know now, sigma, and this is always a positive number. This
Mm-hmm.
is always positive. So if I add a multiple of this to mu, I would land here. I'm adding something positive to mu, so I will land ahead of mu, if that makes sense.
Mm-hmm.
I'm adding a kth multiple of standard deviation. K is just an integer. K is just a number,
Mm-hmm.
right? You can say a positive integer. So mu plus k sigma will be somewhere here, if that makes sense. This point. Similarly, if I subtract the same thing from mu, I will go an equal distance back, mu minus k times sigma, right?
Yes.
So all Chebyshev did in his entire life was to find what percentage is this green area
Mm-hmm.
of the total red area, the total area under the curve. What is the percentage of that green in the total red? Does that make sense?
Mm-hmm.
And he concluded that the green divided by the red
Mm-hmm.
is greater than or equal to 1 minus 1 upon k square. That's the formula. So this ratio, he did not find an exact answer, Layden.
Mm-hmm. Mm-hmm.
He found that it is greater than or equal to this ratio,
Mm-hmm.
right? So let's take a quick example and it will become absolutely crystal clear to you. Mu, let k equal to 2. So mu plus 2 times sigma, right?
Mm-hmm.
And mu minus 2 times sigma.
Yes.
So then this area, red area upon total area, which is the total area under this curve,
Mm-hmm.
right, is greater than equal to 1 minus 1 upon 2 square. Does that make sense? Is it straightforward?
And you got the two. Oh, because K. Oh, yeah, yeah, yeah.
K is 2.
Wait,
So
yeah.
I'm
Okay.
simply just putting K as 2. As simple as that,
Oh, okay.
right? So in other words, can I write this whole thing is greater than equal to 3 upon 4? This is what you will get when you like finally solve this out. So 1
Yes.
upon 2 square is nothing but 1 upon 4 and 1
Mm-hmm.
minus 1 upon 4 is 3 upon 4. Simple.
Mm-hmm. Yeah.
So that again is nothing but greater than 0.75 if you do the math here.
Yes.
So basically just saying that for a value of 2,
Mm-hmm.
this red area upon total area is greater than equal to
Zero
0.75
point.
or 75%,
Mm.
right? So this is minimum 75% of the total area under the curve. That's all Chebyshev said.
Okay.
Does it clarify it
Yeah.
for you now?
Yeah. Big
Yeah,
time. Yeah.
perfect.
Mm-hmm.
So same thing. If I go on and put another value of k, it will be the same thing. If I say 3 sigma now, so k is 3 now,
Mm-hmm.
right? And I ask you, what is the green area as a percentage of the total area?
Mm-hmm.
Then you will simply say, in this example, green area upon total area is minimum or greater than equal to 1 minus 1 upon 3 square. Simple.
Mm-hmm.
So 1 minus 1 upon 9, 8 upon 9, and just do the math and tell me what this comes to. I think it's somewhere around 80, 88.88
88,
point,
88. Yeah.
yeah, 88.89,
Yes.
or actually 0.88 or
Mm-hmm. Right
88.8
now.
percent,
Mm-hmm.
whatever, right?
Yes.
So this green area as a percentage of total area under the curve is around
Mm-hmm.
minimum 88.88%, is actually greater than equal to 88.88%. Make sense?
Yeah. Very clear now. My goodness.
Perfect. Perfect. That's what I like to hear.
I can't
I'm
believe I
happy.
was having issues. You
Yeah,
made
I'm
it look
happy
so
to.
easy.
Yeah, yeah. I'm always happy to hear that. So thank you
Mm-hmm.
so much. And do you still have any questions on this? Is it fully clear now?
Yeah. This one. Yeah. You just. Yeah.
Right. So if you look at this
Mm-hmm.
slide, we have said the same thing. At
Mm-hmm.
least 89% of the values lie in the shaded areas. So 89% of the total values under the curve is
Mm-hmm.
the shaded area. That's it. Right.
Yes.
So let's see another variation of a problem using
Mm-hmm.
Chebyshev's theorem. The average systolic blood pressure for 4,000 women who were screened for high blood pressure was found to be 187 with a
Mm-hmm.
standard deviation of 22.
Mm-hmm.
Using Chebyshev's theorem, find at least what percentage of women in this group have a systolic blood pressure between 143 and 231. So let's see how we do it. What's the mean? This is always the mean. If you look at the problem, can you tell me what's the mean?
Uh, would the average? So would it be 4,000?
That's the number of women surveyed. The average was 187.
Oh, okay.
The average blood pressure for 4,000 women who were screened was found to be 187.
Mm-hmm. Okay.
So the mean is
187
how
is the
much?
mean.
187,
187.
right? What's my standard deviation?
22.
22. So I will just let it hanging in the air somewhere, 22. That's how we
Mm-hmm.
always treat standard deviation initially. Now read the question. Find what percentage of women have blood pressure between 143 and 231. So this horizontal line is of course my X, which is the blood pressures. The mean
Yes.
is 187.
Mm-hmm.
So if 187 is this number, 143 would be somewhere to the left of 187.
Yes.
The usual concept of number line where we say that the smaller number is always on the left of the larger number.
Mm-hmm.
So if 187 is here, 143 would be somewhere on the left, maybe here.
Mm-hmm.
Maybe I can draw a dotted line also.
Yeah.
Yeah, and this is 143.
Mm-hmm.
Similarly, what's the other number that we have?
231.
So can I say that it would be somewhere here?
Yes, because it's positive, so
So
you
you
go
have
that
to
way.
find what is the minimum value of the ratio of this green area to the
Mm-hmm.
total area under the curve. So basically, I have to find 1 minus 1 by k square. So for
Mm-hmm.
that, I need k. That's it.
Yeah. Mm-hmm.
So I want this point is 187 and this point is 231. So how many standard deviations am I going ahead? What do I multiply with my sigma to reach 231?
You
Right?
subtract those two. Yeah. Yeah.
Yeah. So just use a simple formula. We know that this is represented as mu plus k sigma in the diagram. You remember that? So
Mm-hmm.
mu plus k times sigma is how much? 231.
Mm-hmm.
What is the value of mu?
Oh, 80, 187.
So 187 plus k multiplied with what is sigma?
22.
Make sense?
Mm-hmm.
So can I say 22k is equal to 231 minus 187? Just taking the 187 on the right hand side.
Mm-hmm. Yeah.
It will come to 44 if you do the math.
Mm-hmm.
So if 22 times something is 44, then can I say that is nothing but 44 divided by 22? Something multiplied to something when it comes on the right hand side becomes division.
Mm-hmm.
What is that? Do you need a calculator?
Yeah. Oh, it's 2.
That's why I said, right? Very simple numbers here. So
Mm-hmm.
2. So I am going 2 standard deviations ahead. So I know the value of k.
Mm-hmm.
Now I must go the same number of standard deviations to the left also. That's my rule for Chebyshev's.
Mm-hmm.
So we need to verify for 143 also, right?
Yes.
So 187, which is mu minus 2 times of sigma should give me 143,
Where are you
right?
getting the 2 times from? Oh, that's the
I'm
amount
just
you.
verifying whether k is actually 2 or not. So the k is we just found here. This is
Oh, okay.
nothing but mu minus k times sigma, right?
Mm-hmm.
So for Chebyshev's to work, the value of k should remain consistent between this and this, right?
Mm-hmm.
If you subtract k times the standard deviation from this number, you should get this number.
Yeah.
If you add k times the standard deviation, you should get this number.
Mm-hmm.
So we calculated k using this number. Now we are
Mm-hmm.
just checking whether this is also true.
Okay.
So 187 minus 2 times of sigma. Can you do the math? Tell me what it comes to.
44, I think. Yeah, 44.
No, no, 187 minus the whole thing. The whole thing, what does it come to?
Oh,
187
okay.
minus 44.
143.
Is that the number we have here?
Yes.
So now we are able to confirm that k is 2. Yes or no?
Yes,
So
because
1
it
minus 1
gives you
by
the
k
both
square,
answers.
1 minus 1 by 2 square,
Mm-hmm.
which is nothing but 1 minus 1 upon 4, which is
Mm-hmm.
3/4 or 0.75 or 75%. So
Mm-hmm.
minimum 75% of the total area is this shaded area. Or in other words,
Mm.
the shaded area is minimum 75% of the total. Simple. Makes full sense?
Yes.
75%.
Mm-hmm.
Right. So that is all to Chebyshev's. That's it.
Okay.
Right.
Is it going to be on the exam?
Yeah, it can be on the exam, but it's straightforward now for you, is it not?
Yeah, it is. Yeah.
right? And then the last few concepts in your chapter 3 talk about quartiles and percentiles.
Mhm.
So quartiles essentially are summary measures to divide a rank data set into four equal parts. So if I have a rank data set just arranged in increasing order, I can divide it into four equal parts of 25% of data each using
Mhm.
three quartiles, Q1, Q2, and Q3. That makes sense.
Mhm.
So the second quartile is always the median,
Mhm.
right?
Yes.
This is always the median, the same thing that we studied earlier in this chapter.
Mhm.
And Q1 and Q3 are calculated as we'll go through in future slides.
Mhm.
Meanwhile, one intermittent concept for you is interquartile range, IQR.
Mhm.
And that is nothing but Q3 minus Q1. That's it. You find the
Yes.
two and you subtract Q1 from Q3. That's it. That's all you do.
Mhm.
So let's see an example and try to understand how we calculate the three quartiles. Right. Do you remember this example we took earlier? 2008 profits of 12 different companies.
Mhm.
Right. The question is, first question, find the value of the three quartiles. Right. Where
Mhm.
does the 2008 profits of Merck and Co fall in relation to these quartiles? So how do we find the three quartiles? Very simple. First, arrange them in increasing order.
Mhm.
Then the second quartile is the same thing as the median, as I told you. So
Mhm.
if you remember, median was middle two values averaged because there are 12 values here, so even number
Yeah.
of values.
Mhm.
So what is 12 plus 13 divided by 2?
12.5.
Absolutely. And then you are left with six values on this side and six values on this side. So out of these six, also you average the third and fourth, which is 14 and 17.
Mhm.
Out of this six, you average the middle two, which is 9 and 10, if that makes sense.
Mhm.
So by looking at the position of $8 billion, which is the 2008 profits of Merck and Co., we can state that this value lies in the bottom 25% of the profits. So Merck and Co is 8. So 8 is below 9.5
Yes.
because if you notice, Q1, Q2, and Q3 are arranged in increasing order always because these are the medians for a ranked data set.
Mhm.
So if Q1 is 9.5, if you look at this diagram, Q1 here is 9.5, then
Mhm.
8 would fall somewhere here. So that's bottom 25%.
Yes.
If something falls here,
Mhm.
then you say it falls between Q1 and Q2. You don't say top 25% or something like that. This
Okay.
is bottom 25%, between Q1 and Q2, between Q2 and Q3,
Mhm.
top 25%.
Okay.
That's how you speak in terms of quartiles.
So this one is top 25.
This one is top 25, this one.
Oh, okay, top 25, bottom
This one
25.
is between Q2 and Q3. You
Mhm.
clearly see Q2 on one side and Q3 on the other. So this is between Q2 and Q3.
Mhm.
This is between Q1 and Q2. And this is bottom 25. Any
Okay.
questions? Does it
No,
make
got
full
it.
sense?
Yes.
Absolutely clear?
Yes, very clear.
Perfect. And last question is the simplest. Find the interquartile range. So all you have to do is Q3 minus Q1.
Mhm.
Right?
Yes. Yes.
Percentiles and percentile rank. Now, each of these portions contains 1% of the observations of a data set. Similarly, in case of percentiles, we divide the data into 100 equal parts.
Mhm.
Quartiles, 4 equal parts, 25% each. Percentiles, 100 equal parts, 1% each.
Mhm.
The first part, so in order to cut a cake into 100 parts, you need 99 cuts.
Yes.
So the first cut is P1, percentile 1, percentile number
Mhm.
1.
Mhm.
P2, and hence the last one is P99.
Mhm.
Similarly, to cut a cake into 4 equal parts,
Mhm.
you need 3 cuts. First cut Q1, second cut Q2, third cut Q3.
Mm-hmm.
You understand the
Yes.
correlation between quartiles and percentiles?
Mm-hmm.
Perfect. So, how do you calculate the kth percentile? You simply grab the value of the kn upon 100th term in a rank dataset, where k denotes the number of the percentile and n represents the sample size.
Mm-hmm.
Right?
Mm-hmm.
So, let's see an example. Looking at the same dataset, 2008 profits, find the value of the 42nd percentile. How do we do that? We first arrange it in increasing order, and then I have to grab the kn upon 100th term, where k is 42. So
And it
42,
stands for what?
sorry,
The N stands for what?
n is the sample size. I was just coming to that.
Oh, okay. Sorry.
Yeah, so 42nd percentile is what I'm looking for. So k is 42
Mm-hmm.
times the 12 values here. So 42 times 12
Mm-hmm.
divided by 100
Mm-hmm.
equal to fifth term. What's the fifth term in this data set?
Mm, 2, 3, 4, 5. The 12. Number 12.
11.
1,
Fifth
2,
term, right?
3,
1,
4,
2,
5.
3,
Oh
4,
yeah.
5.
Mm-hmm.
So 11 is my 42nd percentile. Make sense?
Yes. This one is pretty good too. Yeah.
And then we have something called percentile rank. So percentile rank is nothing but number of values less than x. Percentile rank of x is nothing but number of values less than x upon total number of values in the dataset times 100. So find the rank of $14 billion.
Mm-hmm.
So how many values do you see less than 14? All of these values. If you count
Yeah.
carefully, how many do you see here from 7 to
1,
this 13?
2, 3, 4, 5, 6, 7, 8.
8. So number of values less than 14 is 8
Mm-hmm.
divided by total number of values, which is how much?
12.
Multiplied with 100. So 66.67% is the percentile rank of this 14.
Oh, okay.
Straightforward.
Mm-hmm.
That's the reason that I always say chapter 1 to 3 is free marks for everybody. And the good news is, from
Mm-hmm.
chapters 1 to 3 alone, you will have 40% of the questions. 40%.
40% of the questions from the exam.
Just for chapters 1 to 3.
That's amazing.
Right? So, this is how you find the percentile rank.
Mm-hmm.
And the last one is about a box and whisker plot. Now, you might not get the construction of it in the exam because that is, of course, not possible. But you
Mm-hmm.
might have one or two questions from here.
Mm-hmm.
So, this is a plot that shows the center, spread, and skewness of a data set. It is, as the name suggests, box and whisker. So you construct a box, you draw two whiskers that use the median, the first quartile, the third quartile, and the smallest and largest values, and then go from there. Simple.
Mm-hmm. Mm-hmm.
Construct a box and whisker plot for this data. You have all of this data here, right?
Yes.
How do you construct it? You first arrange it in increasing order,
Mm-hmm.
then you find all of these numbers. Median, you know how to find median by now?
Yeah.
Q1, Q3, IQR, clear?
Mm-hmm. Yeah.
Just
Those
go
are
on
clear.
finding
Yeah.
these numbers. Yeah. And
Mm-hmm.
then you find these three quantities based off of the previous ones. So we find a special quantity which is nothing but 1.5 times your IQR. So our IQR came out to be 224. So
Mm-hmm.
1.5 times that 24 gives us
36.
36. And then we calculate lower inner fence and upper inner fence. So lower inner fence is nothing but your Q1 or your first quartile minus this number.
Okay.
So what was your first quartile coming to?
77.
77. Minus 36 gives us 41.
Mhm.
Upper inner fence means Q3 plus this number. So Q3 plus 36, which gives us 137,
Mhm.
if that makes sense.
Yeah.
Right. So smallest value within the two inner fences, 69. Largest value within two inner fences, 1112. So what you do is these two fences, 41 and 137.
Mhm.
Now you look at the data and find the largest and smallest values within that range. So if I get the rank data set for you, which is the smallest number between 41 and 137? 69. Make sense?
Sorry, say that again.
So just remember these two numbers,
Mhm.
41 and
Mhm.
137.
Yes. Okay.
Now, between 41 and 137,
Mhm.
out of the numbers that you see here, what is the smallest number within that range?
Oh, 69.
69. Within 41 and 137, what is the largest number on this slide?
144.
Is 144 between 41 and 137?
No, 112.
112.
Mhm.
So, largest value within the two inner fences, these numbers are referred to as inner fences.
Mm.
So, largest value within the two inner fences is 112. Smallest value within the two inner fences is 69. Now, with all of this calculation, we draw our box and whiskers.
Mm.
So, the box simply consists of the median, the first quartile, and the third quartile. So, we draw a uniform scale. If you see, this is uniform, 10 units each,
Mhm.
65, 75, 85. The median is how much? 87.
87. Yeah.
Q1 is 77 and this is 101.
Mhm.
So this is roughly 87. If you see, it's slightly ahead of 85.
Mhm.
This is 77, slightly ahead of 75.
Mhm.
And this is 101, slightly ahead of 95. So
Yeah.
this is called first, third, and median. Now what we do is we draw two small whiskers, largest value and smallest value within the two inner fences. So smallest value within two inner fences is this 69, if you recall,
Yes.
and largest value was 112.
112. Yeah.
These are my whiskers. This
Mm.
144 is an outlier, an extremely large value as
Mhm.
compared to this entire plot.
Yes.
So this is essentially how we use a box and whisker plot to find and analyze data,
Mhm.
right? And the good news is that that is the end of chapter 3 as well,
Oh, oh, perfect. Yeah.
right?
Mhm.
So I'll have my assistant share the recording and everything with you. Go through it
Mhm.
very, very well. And if you have any additional questions, do feel free to reach out,
Okay.
right? Otherwise, anyways, in our next class, when we do chapter 4,
Mhm.
you will have sufficient time to ask questions.
Okay. And I asked the assistant for the assignments, and she said that you have to attempt first. But I already attempt like all three assignments.
You attempt